Okay, today we're going to talk about your eyes, not your ears, not your mouth, not your nose, nor your head, shoulders, knees, and toes. So, we're going to talk about some anatomy first. Now, I know you signed up for engineering because you love anatomy, but you'll be alright. But you have to know what some of the parts are because, we're going to use words. Not all of these words. There's a lot of extra words here because it doesn't matter. But, anyways, here's a picture. This is like your face, it's over there, and here's your eyelids, so they cover up most of this stuff. So the things that you need to be aware of is, we'll start on the outside. You have a cornea. A cornea is the clear part of your eye that's on the surface. So if you put in contacts or something like that, they sit on top of your cornea. All right, your cornea is spherical, has a curve to it. And this helps to focus light into your eye, right? So when light comes in, something like there, it gets pulled, it bends because it hits at an angle, and it goes in because it refracts. Okay, so there's your cornea. Further in, you have the iris. The iris is the colorful portion of your eye. In this one, it's blue. If anyone asks you what color your eyes are, they're asking really what color are your irises. Okay, so your iris is the colorful area. Now the colorful area is able to expand or contract. That will cause the pupil to expand or contract in reverse. In reality, the pupil is just a hole. Okay, the pupil's a hole because there's no light coming out of there. That's why it's black. Now the lens around the pupil can expand or contract because it's got muscles. It's one of these muscles. I think this muscle's for the lens. So, So if the iris shrinks, what's going to happen is your pupils are going to get bigger. Your pupils are going to get bigger, and your iris is going to be smaller. This is what happens when you go to the eye doctor and they dilate your pupils. They give you a chemical. The chemical reacts with your muscles, tricking them into contracting, and then then they can see the interior of your eye much easier. That's that whole thing. Don't mean to ruin it for you. But anyways, this is your outer portion right here. Now, right behind your pupil, you have a lens. A lens is going to be basically like a little bead, right? But it is slightly bendable, okay? What the lens does is the lens focuses the light that's coming in so it reaches a point in the back of your eyes. So it bends it onto this spot there, for example. Now, if you're looking at something closer or further away, it has to change, to focus. So there's muscles going around the lens, 360 degrees, which pull on it or push on it to make it thinner or rounder, right? Does that make sense? So this will change where the focal point is within your eyes, right? So that's what the lens does. If you do surgery, well, I guess old people, when they do cataract surgery, a cataract is when the lenses are cloudy, so that there's stuff in it basically, and then they have to replace it. That's what a cataract surgery does. And when they replace it, they put it like a gel bead in there, like a silicone kind of bead. That way the eyes can still stretch it properly. And they mold it, they measure your eye to have it match really well. Okay, so within this, you have your vitreous fluid or vitreous body. It doesn't matter. It's just some clear liquid, whatever. Because your eyeballs are not hollow; they're more like water balloon kind of stuff. So you've got some fluid in there, which you want to be clear. And then in the back of your eye, you have the retina. The retina is the receiving portion. So this is the part that's going to be taking in all the light. All right? So it's almost all of the backside of your eye. There's one place where the retina cannot receive information, and that is in your optic nerve, because your eyeball is connected to your brain, right? Goes in. But this connection point does not have a sensitivity to light there. This means that each one of your eyes has a blind spot in there somewhere. Now, you cannot see it directly because your brain is smart and it compensates. It photoshops out your blind spot. But if you do want to see it, here's what you can do. You can put two X's on a piece of paper, maybe a couple inches apart. You cover one eye. Let's say I'm going to cover my left eye, and I'm going to be staring at this one. So my right eye is staring at this X. And then if I move it closer or further, eventually this guy will disappear, and that's because it's in the blind spot. And you can do the same thing for the opposite eye. Now, you might have to move it around a little bit because it's a certain distance away from where you're focusing is, because what you're measuring is like this distance there. That's what's happening. Anyways, so that you can do that to find your blind spot. But it's different for each eye. That's why, they don't overlap, because that would be a horrible thing if they were lined up, because that would mean there's a spot you literally cannot see. Anyways, the last thing we're going to talk about is your macula. Your macula is like the focus point. Okay, this is your most sensitive spot for your eyes. Sensitive. So everything else, all this area, this is peripheral vision, which I'm not going to try to spell. Your focusing point is your macula. So this is why it's really hard to read a book or read text in your peripheral vision, because you're very much less sensitive to it. You have way more light sensitive cells in your macula than you do in the surrounding areas. Okay, and it kind of peters off. So like there's a bunch of cells near the macula, and then it fades away as you get further and further away. All right, so this is how your eye is structured. We're going to talk a little bit about how it receives the light, and then we'll tell you some more fun stuff about that. So inside of your retina, you have two types of photosensitive cells. You've got rods and you've got cones. Okay, they are called rods and cones because of their shape. This one looks more like a rod. This one looks more like a cone. Ta-da! So basically, and to give you the short version of chemistry here, a photon hits them and they can react. So by react, I mean they pick up a signal and they pass the electrical signal on to the next cell. So it goes through your nerve cells, right? Your nerve cells just pass electrical signals to your brain, and your brain pieces it together. So your eyes don't really have any input on what you see. They just report it, and your brain takes care of the rest. Okay, and it's the same thing for your cones, but there is a difference between them. So let's talk about rods first. Rods only detect intensity. All right, this means that they only do black and white and gray. Okay, so they just detect if there's light at all or if there's not light at all. That's what rods do. By comparison, cones can detect color. If you want to see colors, you have to use your cones. Now, realistically, you can't turn off your cones or anything like that, but you sort of can, because cones are in your macula. Macula. Okay, I think I spelled it right. If not, I can't see it anymore. So, all right. So these are in your macula pretty much all the way, right? Your rods are in your peripheral vision. So these are not in your macula. Macula. I think it's I. Is it? I don't know. Anyways, so this means that your rods are in your peripheral vision and your cones are in your focused vision, basically speaking. All right, so what this means is if you take a box of crayons, right, and you pull one out and put it in your peripheral vision, it'll be very difficult for you to tell what color it is. All right, it'll be difficult because you don't have cones picking up on that light. Now, of course, there is a spread here, but try it out and you'll see what I mean. Now, there's something else about rods. Rods can work in low light. Okay? So that means at night, when it's dark out, you're not using your cones. You're using your rods, because rods can pick up lower concentrations of light than cones can. So, at night, for example, you can't see color very well. You can't see color because there's not enough light because you're not using cones. Now, to work in low light, they do need a warm-up period. Alright, I'm sure you've experienced this before. Like, when you go to the bathroom in the middle of the night and you turn off the light, and then it gets very, 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 very dark and you can't see anything, but then if you wait a couple minutes, then you can. And that's because your rods need time to activate. Alright? One thing you can do to try this out is if you turn on the light in the middle of the night, right? Even if it rhymes, you cover one of your eyes, right? So you're looking through your left eye, for example, and then you turn on the light and you can see in the bright area, and then you turn off the light and you'll be dark. But then if you open your right eye, if you switch eyes, it'll suddenly open up. So that's bypassing that warm-up period because your one eye will already be focused in on the dark. Alright, so here's your rods and your cones. That's how they work. Now this kind of shows how your rods are around the outsides and your cones are in the middle. Oh, another way you can do this is at night you can see things better in your peripheral vision. So let's say you're trying to look at the address across the street, right? If you look straight at it, it'll be much darker than if you look just a little bit off of it, right? So maybe keep it, 10 degrees off or whatever like that, and you'll be able to see it much easier in the dark, right? Because you have the cones all on the outside here, and you have the rods, you have the rods all on the outside here, right? The orange colored stuff, and the cones in the middle. Now, you can also see from this that you have different cones for different colors. Yes. Alright, you have 3 cones. One cone is focused on your blue lights, right? So it reacts to blue light. One is focused on green light, and one is focused on red light. But there is lots of overlap in this, and the overlap is intentional. Okay? So if Mr. Keeney shines a yellow light at you, alright, your brain will know that it's yellow. How does it know that it's yellow? It knows that it's yellow because the red one will be activated at this level, and the green one will be activated at this level. And this is the only level where these two are matched. Does that make sense? Where these two values are aligned. And then it's the same with the blue one. That's way down there. That's how your body knows it's not like this guy over here, because these ones won't align. Right? And that's how your brain can tell colors apart. It can tell colors apart because it measures the corresponding reactivities of the 3 cones in your eye. So if the blue one reacts very strongly and the green one reacts kind of weakly, it knows that it's a very bluish color. Alright? If the red one reacts and everything else is pretty much not, it knows it's a very red color. And it's going to be over there. And that's how your brain tells all these colors apart. Now, beyond this, remember, you don't have sensitivity for light past this. So it would be dark. Right? This is your infrared area over here on this side. Your eyes don't have the setup to be able to pick up those photons. But that doesn't mean they're impossible to pick up. Night vision goggles work by picking up those infrared ones. And then what they do is they display a screen in front of your eye. So you're like looking at your phone really close and your phone can see in the dark. That's how it works, how night vision works. So that's how light is received into your eyes. Tomorrow we're going to talk more about colors and mixing them together. So fun.